OK， right. So let's continue our lecture. 啊，我还没讲完刚刚的哈，我想要跟大家分享就是我最近就在想说，就以前嘛古代的人就没有机器，没有机器帮忙，所以你就要去耕田啊，你就要走路走很远才能到下一个目的地嘛。那所以在那个时间那个时候的人，他就只要就过生活，你就身体就会自然而然就做到运动。那后来机器发明了，可能车子发明了，耕田机发明了，很多都自动化了。那所以人类就不需要运动了，然后不需要运动，就变成造成很多问题嘛，例如说肥胖啊，例如说很多生病啊、疾病啊等等的。那所以现在就发明的东西叫做健身房，大家就是要去做健身房，然后健身房是有效的去帮助我们去强健我们原本该强健的部位，例如说手背的肌肉啊、脚部的肌肉、背部的肌肉、腹部的肌肉等等等。那这时候我就想AI 出现了是不是也是另外一个自动化的机器呢？只是这一次人类会变成原本的肥胖问题会变成智力低下问题，或者是无法思考问题，或者是记忆力不集中问题。那所以我们未来应该要开一个东西叫做健脑房，对不对？健脑房，然后你就要去里面去健脑，你可能要特地去为这件事情做一些奇怪的题目，然后让自己脑袋活络一点，那不然的话脑袋就萎缩啊什么之类的。那另外一件事情就是所以等于是说现在这种健身房不就是说大家去，有些你可以选择去或选择不去嘛，对不对？好，你去会有好处，对你身体好，会对你的仪表变得很好，然后可能你会得到一些 benefit 一些利益。那如果你不去的话，你可能自己身体会不好，或者是说别人就会觉得说你很懒惰不，就是开始有这种两边的差异，所以到最后就变成是选择问题了。如果你 AI 出现以后有健脑房这件事情，那你就会发现健脑房会让你这个人变得很聪明，然后没有去健脑房的人就变得傻傻，然后只会靠 AI 去养他，这样子。所以我觉得这是未来可能会发生的一些趋势。然后那些健身器材就会发现它不是会有那些举重吗？所以举重现在变成奥林匹克的比赛嘛，对不对？那以后会不会有健脑的奥林匹克比赛？例如说一次背超多的东西，然后就变成健脑的奥林匹克反正这个我就开始乱想一些有的没的我觉得是未来会到底怎么样呢？这样，然后还有另外一个不是会有现在不是会有 F1 赛车嘛？也就是人类跟机器一起比赛，然后赢得胜利，对不对？闪电霹雳车，我不知道这是我小时候的东西，不知道大家有没有看过了反正就是机器车子跟人是机器的车子的 AI 跟人一起嘛，对不对？那以后就会有出现这种东西就会 AI 的机器人或 AI 的车子会跟人一样一起加入到这个运动的行列，这样电竞的行列或者是很多行列这样，所以觉得以后可能就会往这个方向发展，不知道以后讲的对不对反正我现在2025年3月不对5月把它记录下来，然后看以后我会不会说的很准这样。好那我们就来看看吧。Okay, so let's start my lecture. So last time we talked about several topics. We talked about how the efficiency of the bean shape, and then we talk about when we determine the efficiency of the bean, we typically measure the S. Okay, well the S actually is the I divided by the longest distance from centroid. Okay, centroid of the shape, and then we notice that square is better than circle. Okay, and then the best optimized cross-section shape is I shape. Okay, and then we talk about how to build a dam. okay, water pressure, and how to construct the problem and make it a hand calculated problems. Okay, and then we focus on the next problem is that, well, okay, so this problem, we have a fixed support, right? Fixed support, and then we have a point load at the A point, and then I ask you to finish this figure back home, right? So, well, so then I'm going to write the answer here, all right? And before that, we need to specify there are several reaction force at the fixed support, right? RB, and also very important, there's a M here. There's an M here, all right? Because you see the RB is going up to cancel the Fy, right? To make the Y direction force equal to 0. However, you can see that there is a kind of counterclockwise rotation. So you must have some reaction moment to the clockwise at the fixed support. Okay, so here must be something. Okay, so again, after you've done, I hope you go back home and you've done the plots, and then you will notice that the V here is negative all the time. Okay, and then your M is negative as well, and it's well, with the constant slope, because your shear is at constant. Okay, so the constant slope in moment, and then here's minus cos. Okay, the cos. Sorry, minus what? Sorry, minus px. Yeah, I think what is cos? Px. Okay, the minus px. The m here is actually minus px. It's really easy. You see p here, and this is the entire the length of the x. So the px should be, at this point it should be pl, but all the points should be minus px. Okay, well, I should make it, it's better to make it minus px, and it should be pl, minus pl, right? Okay, so we actually know the moment. Okay, and then if you can understand this, we are ready to write down the sigma B at the fixed support. Okay, what is sigma B? Okay, B here in the point here. Sorry. Here, all right? The B point here. And sigma B at fixed support. And also, you see, actually, B point is x equal to A, x equal to B. Okay, I mean, x A point and B point. So actually, the B is actually an entire circle, right? So if you want to know the sigma B, it must be a surface, right? So actually, this problem has some mistake, has some bug in it. So we should specify sigma B makes, all right? Makes. Otherwise, sigma B, you has plenty of them. All the sigma on the section at the point B here will be the sigma B, right? So you have many values, so you cannot easily calculate that and write it down in the problem. So suppose issue has specified sigma B makes, okay, at the fixed support. So what is the sigma B makes? Actually, you have two possible values. The first one is top, the other is bottom, right? So one of them, okay, we don't know. Well, suppose it should be the same, okay, because it is symmetry. And the second, sigma mix. Okay, sigma mix means that actually it doesn't mean that we always get the maxima at the end of the material. Maybe it appears somewhere here. Although you see it has the greatest value of moment, but its area is also changed. So the resistance of the moment is also changing. Okay, so it must be some point that the moment is great and the section is also kind of median. Okay, so you can get the sigma mix in the middle. Okay, in between this. OK， 听懂吗？就是说第一题它其实一开始写 sigma B 嘛，那 sigma B 其实那整面都是 B 呀，哈，所以你要讲 sigma 是超多的，那怎么算？所以它其实应该要写个 sigma B max 啦，哈。那既然 max 的话，就是要么就是上面那点，下面那点，其实差不多值，因为它是对称。OK， 那另外一个它是说 sigma max 整个 material 的 max， 那你可能觉得说，哎，为什么不是最后一个啊？最后一个它是最大的弯曲，哎，可是它这边也是最大的面积呀，对不对？面积表示它有越大面积，它可以抗弯越大，所以搞不好它就抗下来了，它的 sigma 很小。但中间就是哎，可能有一个部分就是它的力弯曲很大，但是它的面积也蛮小，还蛮小的地方，那就是一个甜蜜点了哈，它就会有最大的 sigma max。All right, so again, here we are going to determine the function of this shape. Again, we have done this many times, so don't be afraid, right? Although I know this is exaggerated, all right? I'm sorry, but we have done this before, right? This is the A half 2, the A half, okay? And this is dx divided by 2. Sorry. This is dx divided by 2. And this is x, right? And this is db, db divided by 2. Okay, so you know you have seen that before, right? We have done this. Maybe this is the third time. All right. So dx divided by 2 minus the a divided by 2 over x. So it's equal to db divided by 2 minus the a equal minus the a over 2 and L. Okay, so you have the x equal to the a plus the b minus the a x divided by L. Okay, so you get the change of the function of the diameter of function. Diameter is a function of x. Okay, so your Sx equal to pi the x3 divided by 32 and equal to pi over 32 the a minus plus the b minus the a xl3. Okay, your sigma mix. Okay, sigma mix will equal to mx divided by sx because sx has c1 and c2 in it, right? So when you determine the sx, you naturally get the circle like this, and this is the neutral axis, and this is C1, this is C2, right? And of course, this one and that one will be sigma B1 and sigma B2. Of course, they will be the same value, but positive and negative. Yeah, positive and negative. So it's positive and negative. Pi. Oh, it's ugly. Sorry. Hey. Huh? Hey. Hey. Oh. Can I copy this? Yeah. Uh-oh. 哇，就是偷懒的结果，没有好好的分配位置。Okay, so SX and PX, MX is PX, PX, right? So now you have the sigma mix along this material. Okay, you can just substitute X and obtain wherever you want. Okay, so you have sigma B mix. So you will make X equal to L, and your dB equal to 2dA. Okay, wow, 2dA. Okay, so sigma B mix equal to positive and negative 4PL pi dA3. Okay, now next one is more difficult. More difficult because you don't know where is it the sigma mix happened, right? So sigma mix, where should we find that? Because we have the function. All we need to do is do the differentiation according to the x equal to and make it 0, so you can find the optimal value, maximum or minimum value. Okay, 32p. So that's the reason why we need to learn the course of calculus for all the material, all the engineer department student. BA times x divided by L minus 3 plus 332px. I actually did this by myself. A plus dB minus dA x divided by L minus 4 times dB minus dA divided by L equal to 0. Wow. And then x equal to half. Okay. I don't know if your calculator can solve this automatically. I don't know. But there's a trick. There's a trick that if you just enter all these function in your calculator, and you can substitute x whatever you want, right? And then you can just substitute the value. And then if you get 0, which means that you solved that successfully. All right. So maxima 1 to A P L 27 pi d A3. Positive and negative 4.741 PL divided by PL divided by ID A3. Okay, that's the answer. Right. So the most difficult part for this is actually to determine the function of the sigma mix as a function of x. Okay. Right. 好，这一题我觉得不难，但是概念不难，但是计算有点难了哈。那基本上就是找到它的 sigma max 在这里面在这个材料里面。那如何找到 sigma max 呢？我们上次有提到嘛哈，就是mx 除以 sx 的话它就会是得到那一个面的 sigma max。因为这个 x 本身就会有包含这个 C1 跟 C2 的 information 在里面，对不对？尤其是它又是对称的，所以要么就是 C1，要么是 C2，然后一个是正，一个是负。OK， 那这边这个找到这个式子以后，你其实基本上你每一个点在这个材料里面的 sigma 都可以算哦，还蛮厉害的。那第一小题很简单，就直接带 x 等于 L 就带你算出来了。但是呢，如果是叫什么？后面第二题就蛮难的，你要做微分等于0然后你要去算出这个式子。哇，那这个，这我真的是自己去积分的，微分等于0然后你要去算它的答案。那我这边我不知道现在的计算机可不可以帮你这样算了，应该可以吧，对不对直接输入然后算最大值。我记得现代的好像可以，但我以前的好像不行。我以前小时候跟你们一样大，20年前是不行的。那所以我那时候就是打上这个式，但是它可以它那个计算机它可以做出一个东西，就是它可以写出式子，然后让你随便带 x， 它就帮你算出值来。所以我就把这个式子算出来 ，s 打进去以后，我就开始狂按 x， 狂试 ，iteration 就是迭代，x 一直试，看那个这会不会等于0？如果不等于0，当然就是这不是这正确值。然后一直带，越来越靠近0了表示我答案对，大概是这样。我小时候大概是这样子，用逼近的方法算出这个式子的，都可以啦然后就可以得到这个 sigma mix。Alright， 有点复杂。Alright， and we also need to positive and negative. Where is that? It is referred to the top and bottom. Alright, so you need to be careful. Okay, so now we know how to determine the normal stress. You see, the stress is sigma x is along the x-axis, right? So you can see that this is a compression or tensile for the section. Either press the section or tensile the section. Okay, So you can see that this is normal to the section, normal to the section. Next, we are going to determine shear stress on the surface. You see the shear stress will be parallel to the section, all right, on the plan, on the section plan. So it will be really, well, another things very difficult, all right? And next proof is a little bit complicated, but still fall into the categories in mechanics of material that all the proof, 95% of the proof is based on stress times area and then do the force balance. Okay, so concepts are all the same. Next one, shear. This is really difficult, all right? So let's continue. So here you see this is X. Okay, so, well, I can just directly write it down. It's too simple. Okay, this is X. Suppose this is Y and Z toward you. So this is side view. All right, this is side view. This is side view. All right, and you see that if we cut it, and then we can see this is V and this is M. This is V plus dV, and this is M plus dM. Where is the dV and dM from? It's something here, right? Either distributed load or either moment or either point load, any, I don't know, okay? But it must be after this dx distance, the right-hand side must have some difference of dV and dm. Okay, so if you can accept that, yeah. Now, okay, very difficult. All right, so now we are going to see a beam for the rectangular cross section. Rectangular cross section is here. You see, this is X, this is Y, this is Z. All right. So you can see that if you want to see a cross section like this, the cross section like this, okay, it is actually here. All right. Okay. And please, you can imagine that actually this N and N1 is very close to each other, very, very close to each other. Okay. So that's why I just plot this yellow section in the middle. All right. Now, let's write down a stress element at that place, and which is in 3D. Okay. You can correspond to this. All right. Okay. And we are going to see, we want to see the shear on that surface. Sorry, on the surface of the element. We want to see that. Okay. And of course, this element is kind of above to the neutral axis. Okay. I want to see certain height of Y. Okay. And I want to see that position, What is the shear value, shear stress value at that surface? So this is actually corresponding to this stress. All right. Okay. However, this is really difficult to determine. We have no idea how to determine that. How can I do it? How can I do it? We don't know how to do this. This is really difficult. How can we do it? Luckily, remember that shear stress come in pair, right? So if you have this one, how it also tell you based on the equilibrium theory, right? Equilibrium, force equilibrium. It must has the same value of the other 3 shear stress. Okay? So this is really difficult. We don't know how to determine it. How about we determine one of them? If we determine one of them, we automatically determine this one, our target, right? So actually, horizontal shear stress is easier. So now I'm going to determine this one. Our target is this one now. Because if we could determine this value, it automatically tells us this has the same value, right? So now we are going to calculate this one, okay? How can we determine that one? If we want to see some stress in the material, we cut it, right? So we cut it, we cut it, we cut this surface. We cut this surface, okay? So which means that if we cut this surface, and then we can see the bottom will be this shear stress, okay? So this pink will be appear in the next page, all right? This pink square rectangle, okay? So again, I will tell you that this is difficult. This is difficult, and this is easy. Okay? Okay. So we have the shear stress come in pairs. But this one is difficult, although this is our target, but we don't know how to do the work balance because it's a very sharp direction. We don't know the boundary condition for this, but we know this. We know the left hand side and right hand side. Okay? So horizontal is easy. So we cut this to get the shear stress in the bottom layer, bottom surface of this pink rectangle. All right? 听懂吗？就是说啊，我们现在要算的是这个矩形截面积上的剪应力哦，但是啊，你可以想象这个剪应力，它其实是它一定是贴平在这个截面上的嘛。那你也可以想象，就是说它一定跟中性轴的距离一定有关系嘛，有可能越来越大，有可能越来越小，我不知道，等下算了再知道。OK， 然后呢，我们就想说，哇，这个其实很难呢，水平的超难的，你根本不知道它的这个分布啊，你也不知道怎么平衡啊，不会。运气好的事情是 shear stress 剪应力它是成对出现，所以如果今天这个出现了，另外3个一定出现，那这个的水平的比较好算。怎么算呢？我们等下就切上面这个粉红色这一块，然后做力平衡，然后就可以把下面这一颗西格玛算出来。算出来这个涛，我自然也知道这个涛是多少。OK， now this is the rectangle I mentioned in the previous page. All right. So again, this. Okay, now I'm going to ask you bonus. All right. Is this a side view or a cross-section view? Anyone? bonus. This is a cross-section view or side view. This is really important, no? Please. Side view, exactly. Very nice. Very nice. Ta-da, side view. Plenty of senior think this is cross-section view because this is a rectangle. Okay? Very difficult. Right. So please tell me your number. 111613. Sorry, 0.037. Good. Okay, this is side view. Okay, so yeah, you see this, we plot this at side view, right? Here. So now, if I draw this here, okay, and then we make it a little bit oblique, so you can see this. Okay, this, you know this is cross-section view, right? This is cross-section view. All right. I believe you understand now. And this is a side view. All right. So now you see we cut it and then we have tau here. And what is the normal stress for the top layer? I mean, the rectangle. Remember that this normal stress, we just learned how to determine that, right? It is like this, right? So if you cut it, you end up has something on the top. And the left-hand side also has similar value. Okay? Right. Well, not similar values, not similar distribution. All right. So we need to do calculate the left-hand side area stress and the right-hand side stress and then bottom layer tau. Okay. And remember, so maybe you will ask why there's nothing in the top. Because remember that we only focus on the force at the xy plane, right? So it must be like this, or distributed load, or a moment. So we don't have any force for the y direction. So we don't need to consider the top. All right. So we only consider left, bottom, and right. Okay. Left, bottom, right. So now horizontal stress. What is the horizontal stress for the left hand side? Sigma 1 equal to minus my divided by I. Remember that here is m, right? M. Sorry, m. Okay. But right hand side is m plus dm. So m plus dm will be the right hand side. It will be sigma 2 equal to minus m plus dm y divided by I. Okay, so you see the only difference is that this is m. This is m plus dm, right? But it's a sigma. And what is the bottom stress? Tau, right? This is what we are going to determine, although we don't know what is that, but we just write it down, tau. Okay? So now, what is total force for the left-hand side area? Times the area. We just do F1 equal to sigma 1 times dA and do the integration. Okay, so this is my divided by I dA integration. Okay? And later I will give you, I want to ask you to emphasize this minus, and this is integration. And this is minus. Later, I will write down the right-hand side, okay? So I will give you another place. F2 equal to sigma 2 dA equal to minus m plus dm Y I dA. Okay. Oops, sorry, not this. It should be dA. Okay. So here, I would like you to see why there are two minus, but you have positive here and negative here. Okay, because here is compressive stress. Compressive stress. Compress, right? Compress. Yes. But when we want to do the total force balance, we have a rule, right? Right hand side is positive, left hand side is negative. So here is right hand side. So this is positive. All right. So here the force will make it negative. Okay. So that's the reason why you can see this actually not related. Okay, not related because this just tell you this is compressive, but the force will let you know the direction of the coordinate. All right, so this is quite difficult. You need to be careful about this. All right, and next, how about tau? And tau here is okay. We need to get the real value of the dx, dA, dx, and b, right? So you have F3 equal to tau dx b. Okay, so that's how we show, how we prove that. 这样听懂吗？哈，这我觉得有一点点难了，不过也还好啊。就左边就是压应力压进去嘛，所以它是负的，没问题。右边也是压应力嘛，也是负的，没问题。那左边是 m， 所以 my 嘛，右边是 m 加 dm， 那就是 m 加 dmy， 这很简单。好，这个没有问题。下面就是 tau 啊，没问题。那你要看哦，tau是右边嘛，然后左边的那个也是往右边压。右边的是往左边压，哦，这边就有问题啦。当你在做积分的时候，变成乘上面积的时候，它就变成力了。这个力呢，就跟你的方向有关啦。哦，你要做力平衡嘛，所以往右为正，所以你看到这边这边就为正哦。所以这边负，这边负，就一个变正，一个变负，要小心哦，因为它这是往右，那这是往左。OK，这边要非常小心。所以这边的正负号其实是没有关系的哈，没有关系的。那当然这边也是往右的话，那就是它是正 tau dxb，tau dxb 就是它的底部的面积嘛，哈。So if you have three components, left hand side, right hand side, and bottom side, nothing on the top. So fx summation equal to 0 will be the next page. So force equilibrium, okay? Force equilibrium. So you see F1, F3, F2, okay? And right. So I will continue our lecture after 10 minutes. And if you have any questions, just come here. All right. Thank you. 刘老师是我的好朋友。我来刚刚分享胃食道逆流的事情，胃食道逆流。相信我在你们这个年纪的时候，我也是健康的像什么一样，像牛一样，怎么熬夜都没事，不用睡觉也没有关系。小时候就是这样，但是现在就是稍微熬个夜，就是比较忙，然后就熬夜，然后就胃食道逆流。什么叫胃食道逆流呢？你就躺着，其实也没有怎么样，你就会觉得不太舒服，就胃就在那边咕噜咕噜咕噜，然后麻烦的是第二天早上起床，你的喉咙是痛，非常痛。然后我一开始会以为说，哎，我感冒了，我喉咙痛，等等，不对哦，是因为你胃酸侵蚀你的喉咙，对，你的喉咙痛。哎，然后我就跟他聊着，他就说，哎，其实他也有这个问题，然后他就告诉我一些解决方法，这还蛮有趣的，蛮好玩。对，就这样。哎，大家好好保护自己的身体。然后我就在想啊，哦，又在想，你看我每次都乱想一些事情，就我在想，台湾人不是大肠癌不是都非常的严重吗？高居什么什么世界什么什么，然后最重要的最常见的癌症就是大肠。我后来觉得，只要一个东西反复发炎，你就很容易大肠，就是很容易得癌症嘛。其实这样想也没错哦，就是因为你看它受伤，然后你就修复它，受伤修复，受伤修复。但你在这个过程中的时候，你就会身体就会一直产生东西嘛。但是你如果一不小心，你总会有几率产错吧？你一产错就变成癌细胞，然后就掰了。这样好，我就在想，大肠癌这个东西会不会跟我们不能喝牛奶有关啊？因为我发现我不能喝牛奶，就是发现因为我每一次喝完牛奶就会肚子就不舒服。那而且这个东西是会累积的哦，就是如果今天我有很久一阵子没有喝牛奶，然后稍微一点点牛奶我是没事的，但是现在是当时就是一直在发炎，身体就在发炎，然后长痘痘啊，然后什么全身都不舒服啊，但是我还是照喝牛奶，因为我太爱喝牛奶了。然后我就想说，哎，那这样不就是一直反复发炎？所以就是说，你没有去管这种小事，这种平常小小的事情，它长久累积下来，就变成你的癌症。所以搞不好你就是肠燥症，常年的肠燥症，到后来就变大肠。我觉得可能是这样。当然啦，这都是我的随便的推测哦，千万不要相信我哦。我只是有没有可能有关系呢？这样，嗯，所以然后另外一件事情，我又发现，然后我还有另外一个很大的缺点，就是跟大家聊一下，就是我的我会睡觉的时候，每次去咬我自己的舌头。请问你们会这样吗？睡觉不会咬自己的舌头？我从小就会这样我从小就会这样。小时候应该没什么压力吧，所以我就是，例如说我坐在车上行驶之间，然后就睡着了，然后会被我自己摇醒，呀，然后就醒来了，然后超痛，然后我就在想，这到底是为什么？ 其实搞不好这个功能已经救过我的祖先了，因为我坐在那边睡觉，不是躺着睡，所以坐在那边睡觉其实不是一个该好好睡觉的时候。然后，所以我的祖先可能因为这样，就提醒自己说：“哎，你要起床，你不能在那边搞不好被野兽吃掉啊！”我觉得可能是这样。好，总之我可能是因为这样，所以才活到现在的。好，就是祖先没有被野兽吃掉，所以我才可以活到现在。然后，但是我就是一直我就一直咬自己的舌头，然后近几年又越来越严重，可能又老了吧，然后压力大，anyway，所以我在睡觉的时候就一直咬我自己的舌头，舌头咬到都是每天早上起来就是超痛，然后就流血，然后唉，怎么这样？那这时候我就在想，会不会会不会得到那个舌头癌啊、口腔癌？因为他就是一直被咬，然后受伤，然后会不会得到舌头癌？所以我就很害怕，我不能放着不管。但是其实也不太会痛哦，就是也没有到流很多血，反正就咬了一下，然后就痛了一下，痛醒，然后继续睡，然后第二天早上好像也可以当做没事，没这回事发生的，所以我就在想，还是要解决这个问题，所以我就去定做了一个牙套，像 Curry 那个牙套，你知道吗？像第二天，然后晚上睡觉就要把它凸起来，越老越多问题，真是太麻烦了。好啦，就这样。OK, next one. Right. So we just make the stress times the area. So we can have the force, three force. Okay, total force, total force, total force. Force equilibrium, F3 equal to F2 minus F1. All right. So we substitute all these stuff. Okay. So tau, okay, tau B dx equal to dm divided by I y dA. Okay, and then we can b dx to the right hand side. So you can see that tau equal to dn over dx. All right, and IB, right? IB of okay, and YDA. And then you see, wow, what's that? This is the slope of the moment. The slope of moment is what? Shear force, V, okay? And YDA, what is YDA? What is YDA? YDA is equal to V Q divided by I B. Do you remember Q? What is Q? The first moment of the shaded area about the neutral axis. What does that mean? Okay, so this is the first moment, right? The first moment. Remember the YDA Q. Sorry, let me refresh your memory here. YDA QX, right? So this is the first moment, right? Remember this, right? So let's go back. So Q here is the first moment of some area. What is some area? Let me draw here. So now this is not side view anymore. It's a three-dimensional things. And be careful. This area, okay? Because where's YDA come from? Where does YDA come from? it's from left hand side and right hand side, right? So this YDA is actually cross-sectional thing, not side view things. No, no, no. So this Q is the cross-section thing. You cannot make it pink thing, okay? The side view thing. This is different, okay? So a lot of senior think, this Q is here. No, please. This is green, okay? It's a cross-sectional things, cross-section. Because this YDA is come from your cross-section, right? So be careful. Okay, and then be careful. What is this Q? What is this first moment of the shaded area about the neutral axis? Should we actually do the area integration? Well, no, we don't need to do that because we know the concept, we know the definition of the Q, right? The definition of the Q is the distribution of that area corresponding to the axis, right? So actually, all we need to do here is we get the green area centroid. And then we get the Y value of that centroid. And then times the green area. Okay, so it will be a lot easier to do the integration, area integration. All right， 听得懂吗？就是我们这个 YDA 剩下来的，这个 YDA 是从哪来的？是从左边跟右边的这个截面积上来的，对不对？我们那时候是靠那个弯矩的那个公式来的 ，my 除以 I 嘛，对不对？所以这个是截面积上的哦，截面积上的这个 YDA 积分哦，千万不要把它以为是这个粉红色的哦，哦，这个是 side view，一个是侧边，一个是截面的边哦，这不一样哦。好，那这边是 Q 是什么？还记得吗 ？Q 是这个面积对于某个轴的分布状况嘛，对不对？哈，那这个分布状况其实要积分当然是可以，但是对于这种已经知道形状的、很正常的形状的，我们可以做一些简单，就可以做简化。其实就是这个面积的行星，这个面积的行星跟这个轴的距离，这个距离 ，OK。这个 y 的距离乘上这个面积就好了。因为你如果要做积分，其实也可以啦，哈，就是这个小面积，然后乘上这个距离，这个小面积乘上距离，然后这个小面积乘上它的距离，全部加总起来还不是一样？你就等于这个，因为它是平均的嘛，在这中间呢的距离，然后乘上它整个面积，好，所以答案会是一样，好，你可以去做做看，但是不用了，哈。所以这个 Q 就会是。你要看的那一条线的上面的截面积乘上它的面积的行星到中心轴的距离，很绕口哦。下一页我会讲中文，下一页我给你 definition。All right, so very important. So now, tau equal to BQ divided by IB. Okay, so important. Where Q equals to blah, blah, blah. Okay, and then, now, this is cross-section view. Because here's Y, this is Z, all right? And X toward you. Okay, so this is cross-section view. Be careful, all right? So, this is ring area. And we want to know the value of the shear stress at this line, all right? And this is tau, of course. Okay? So, first moment of the shaded part of the rectangle will be, so let's just give you a quick question. Q equal to area times the distance from the centroid of the area to the neutral axis. Actually, I translate in Mandarin in the previous page, okay? So, the Q here, Q equal to, okay, hey, B, okay? How about B, okay? And H over 2 minus Y1. What does that mean? It's actually this one. H over 2 minus Y1. Y1 is the height of the height that where you are going to determine the shear stress. Okay? And what's that? Y1 plus half H minus Y1 divided by 2. Whoa. Well, it is this one. Or if you want to see more detail, this is that. All right. I already try my best to correlate by the color. All right. So this is the value. Blah, 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 blah. And the shear stress equal to tau. So this is Q can be substitute this back to here. So we B divided by 2I. Okay. And B can cancel. Okay. Now, so this is the value of the tau, the shear stress in all these sections. Okay, you see, because you can change in y1 equal to 0, and y1 or equal to c1, y1 equal to c2. So you can determine all the value in this cross section. Okay, so you can see this is shear. This is shear. You can determine every lines in this section by this value, by this function. Okay, so you see this function is parabola 二次曲线. Okay, parabola means that if you determine y1 become c1, what is c1? Half h. Half h become 0. Okay, so tau here is 0 minus half, also leading to 0. And if this y1 equal to 0, it will has the maxima value. So you can imagine that this is side view, okay? The magnitude of the shear stress will be 0 at the top and the bottom, and the biggest at the neutral axis. All right. This is X. This is Y. Okay, so very important. All right. And I will say this is very important equations. So please memorize it and know how to prove that. Okay. And the most difficult part here is Q, how to determine Q. Okay. Right. So I will give you more example later. All right. OK， 听懂吗？哈，我们这个式子就是适合这一整个截面哦，因为这个截面你可以看到这个截面它自己有它自己的 v 嘛，那这个 v 从哪来的啊？你就是画那个简历万元图，到哪个位置，它的 v 就是那个位那个值，然后那个右边这些 q 啊什么，它都是可以，就是你可以算出来，然后 y1 是可以任意改变的，y1 要么就等于0，就中性轴，然后 y1 可以变高变低。那 y1 如果变成 c1 的时候，也就是这边的是h 的时候，你就发现这边是0，负的也是一样，这边也是0。那0乘上多少就是0了，所以说你会发现最高跟最低的剪切应力是为0。OK， 所以你会发现它是一个二次曲线这样子。All right. Oh, one more thing I can let you know to make more impression on it. All right. Remember that we said shear stress come in pair, right? You can see that this stress element has almost zero shear stress. Also means that this place, this surface, okay, this surface is shear stress free. Shear stress equal to 0. Okay, so here shear stress equal to 0, shear stress equal to 0. So that's the reason why this small stress element has zero shear stress even at cross section. 听懂吗？还记得我们刚刚讲的剪切应力是成对出现的吗？所以说啊，这边的这个面等于0，这是也代表你的表面上表面跟下表面其实也是 shear stress 等于0哦。OK， 很明显吧？因为你这个力就是这样压下去，或是平的什么 distributed load 分布载重或是弯曲，根本没有这种剪切应力啊，对不对？哈，没有嘛，啊，所以说这种上下的表面，这个上下表面它 shear stress 等于0，那也表示说，就在表面上一点点的地方，它的这边的垂直的这个 shear stress 在表面上的那个小 stress element，它也是等于0，然后慢慢的变大，然后再回归到变小。Alright， 所以你可以想象一下，我们常常都会说边界条件 （boundary condition），你有没有发现这有点就像是边界条件？你不管怎么样，你外界就是要 shear stress free 啊，所以里面不管怎么动，不管你怎么算，你的边界就是要符合这个条件。所以在做力学的计算的时候，边界条件是非常非常重要的。OK， 如果你边界条件弄错，你内部的这个分布绝对是错的。OK，so that's the reason why boundary condition is so important in mechanics, because you see what I say here is shear stress free, which means that your shear stress distribution need to obey, must be 0 at the top and the bottom. Okay, so if your boundary condition is wrong, maybe you get a value here, a value there, so you won't have the great or good distribution in between, so you'll never be correct. All right, so boundary condition is so important in mechanics of materials. Right? Yes, I guess you can understand this. So now I'm going to give the limitation. We finally can determine the shear stress and normal stress in the section, right? So we are good. Yeah, we 好棒棒. Okay, so limitation of shear. We still need to know the limitation of what we learn. Okay, linear elastic beam. Of course, everything we discussed is linear elastic material, and the edge of the cross section are parallel to the y-axis. We need to have certain the rule here. We need to follow this shape requirement. For example, because we just say what we prove is based on rectangle, right? Z and Y here. So our formula, shear formula, is based on this. So this big value, and this is relatively small value. Okay, so here, okay, good, okay. However, if we have a triangles cross section, can we do that? No, not okay. Okay, not okay. Why? Because we need that, we assume that the stress element with the stress element here is has this kind of shear stress parallel to the y. But now your shear stress is actually like this. So, but our assumption is that we need to make we need to make the shear stress parallel to the y. So we cannot do that. We cannot do that. Okay, not okay. So we cannot apply to this. Okay. However, we can have one special case, luckily. Okay, luckily we have one special case, which called circular. All right, circular is kind of special. Circular is a little bit special here. You can see here, okay, the boundary follow the y parallel to the y. That's good. So this is okay. But here, not okay. All right. So for the circle, we only can determine the value at the neutral axis, and the Q shape will be looks like this, just half circle. The Q shape will be looks like this. All right. So this is special case that circular can, we luckily apply our shear formula. All right. Yeah, very difficult. Okay. And we will expand this more later, maybe tomorrow. All right. But firstly, we need to know that the problem we prove is based on rectangle shape. So there's a limitation. Otherwise we don't know the area. We don't know how to determine the area. So we cannot apply that times that to the shear stress, right? Okay, so now let's continue to determine the shear strength. Okay, we have a shear stress. Now let's take a look at shear strength in the next page.其实我每一年讲的东西都差不多，所以我都不确定我到底有没有讲过。请问我有讲过色盲的故事吗？有吗？没有，都没有，真的啊？我靠！我刚不是说我把所有的东西都用颜色来表示吗？就是绿色就是代表这一段，黄色代表那一段，橘色代表那一段。OK， 我很自豪这件事情。我说，嘿，你看我教学会把那个颜色把它弄得很清楚，然后让大家可以直接连接。但是实际上我每次讲完这个，我心中都会有一个担心。为什么？因为真实发生在我的世界的事情，就是我那时候去英国念书的时候，我的老师跟他的老师是同一个系，懂吗？也就是说施工是同一个系，就对了。那所以说，我的老师跟我在讨论，第一年在讨论的时候，讨论完以后， 因为那时候我的老师也是新进老师啊，哦，他大概是第一年、第二，我是他第二个学生这样，所以他指导我的第一年，他就说，哎，这样好了，我们一起来把我做的东西报告给他的老师，也就是我的施工厅，OK。那施工真的是，应该说他们俩都是极度天才的人啊，哦，他太厉害了，那我都是要拜的那种。那我的老师说他的老师也就是我的施工更是天才，好，然后就开始准备。我那时候准备准备东西是一个叫做铁电材料，铁电材料呢，它有很多的微结构，还有很多 domain，OK，所以那个 domain 在，例如说 tetragonal，它有6个 domain 的 region，所以我就很开心，我就把它6个 domain 都弄了不同的颜色，哒哒哒哒，哇，很漂亮，我还特地精选那些颜色，哦，就不能让它用预设的，我要把它弄得很，然后扣的都把它打得很好，哇，精选漂亮的颜色都弄好，然后我就开始说啊，我就做好了投影片，然后在前一天要报告的时候，我就报告给我的老师听。我说老师，这是我准备的报告，我明天就要这样子报告给施工听，然后就报告哇，这个很漂亮的东西，然后这边对应的第一个 region 在这里，第二个 region 在这里，都用颜色来表示哦。然后我想说哇，这个做的很辛苦，然后我老师就说做的很棒，但我忘记告诉你一件事情，就你施工是一个色盲，他完全看不懂，无法分辨颜色。然后他就说，对啊，你没有发现他每天都穿一样的衣服吗？我说哦，对耶，他都是天天穿一样的衣服。然后他的 paper 出的 paper 全部都是黑白的。那要怎么样？就那时候，那个20年前，20年前其实不太在意那种漂亮 nature 那种，现在的投影片现在的那个封面都要求漂亮啊，这样这样。但是实际上那时候就是比较朴实吧，我猜。然后他都用黑色的线、灰色的线，就黑色跟白色这样。那些线要怎么表示呢？就用虚线或是 marker，所以它都是用黑白。然后我后来才发现，哇，真的是这样子。所以我那天晚上就熬夜把全部的颜色都改成，原本是红色的话，我可能就要改成这种叉叉的那种格子，然后其他的我就要改成斜线，然后是横线，然后这样，然后改了超久。然后我后来就想到，就是说啊，我们太把这些事情当做习以为常，然后就有的时候对方是不知道对方有什么样的背景嘛，哈，我们就是要小心。但虽然我这样听到，就是说啊，以后我们做这些图啊，哈，就是要小心有色盲也在看这样。那对，但是我不好意思，我还是很还是用颜色哈。那我没办法，我不知道该怎么做。哎，那所以之后就是如果我记起来的话，我就会跟大家说，哎，如果各位同学有色盲的话，你可以私下传讯息给我，那我可以帮你解释一下，或者你看录影就可以知道我这一条线在画哪一条，这样。对，就这样。那告诉我，这让我学了一课哦，就是哦，然后另外一件事情就是，你有没有发现他就是天才，他是天才中的天才，所以这也告诉我们，上帝给你关一扇窗，哎，关一扇门就给你开一扇窗，哦，就是你看这位色盲就非常的聪明哦，是我认为天才的老师的老师，还有更天才这样，哇！然后他很厉害哦，他那时候看完我的东西，我成功的把它报告完了嘛，哈，然后他就说，我觉得你这东西之后可以做某某某某事情。然后我就 OK OK OK，但是我想说那太久吧，那以后的事，我先把这个东西解决完再说。结果3年后，我就真的做到后来就发现，哎，没东西好做了，好像真的顺的做就会做到我那位师公说的那个东西，所以后来我就好真的就做那个东西了，然后我们就发了一篇acta materialia 哦 acta 哇 acta 是材料算和金属嘛哦，就最厉害的一个期刊哦第一名，然后反正我本人有2篇，不算厉害，2篇，然后每一次发那篇 paper，我都是一整年，就是都花在里面的，就我的心血的话，半条命都没了那种。那其他老师当然都很厉害啊，就会有7、8篇啊，很厉害。我没办法，但是我只是觉得说， 那位师公哦，就是真的是很天才，然后他就是在3年前就预想到我3年后要做的事情。哇，好，讲完了 ，next。OK, effects of shear strength。但我现在已经懒得把刚刚的故事用英文讲出来了。I'm sorry. Okay, so this is the deformed shape. Okay. Previously, it looks like this. Okay, previously it looks like this. And after the P here, it will deform like that. Okay, and you can imagine that so previously it has a line here, element here. Okay, and this element is supposed previously locate here. All right. So remember that this shear, there's nothing shear, no shear stress here, no shear stress here. So suppose this line or this stress element will maintain in the same shape because no shear stress, right? So it will look like this. Before and after deformation. And this line just will maintain the same. But you can see that in the middle, it has greatest shear. So it will has it will has a shear stress, makes the element become I forgot that how to say that. How to say that? 平行四边形，我都忘了，对不起，我10年来我没有记得过一次。Become that shape, all right? But you see, because this twist make this line twisted in the middle. So it will make twisted in the middle. So it kind of make this line to the back a little bit. All right. So it will make this kind of move a little bit back. Okay. So if you draw a square on the surface of this material, draw this and draw that. Draw these two square before the deformation, and after the deformation, it will end up looks like this and that. All right? 听懂吗？就一开始的时候，如果你画一个这个方块在这里，还没有做任何的变形的时候，画2个方块在你的材料表面上，然后就开始拉它。理论上来讲，上面这一颗就会有点往后移动一点点，然后中间那一颗就会变成平行四边形，因为这个剪力的影响。OK， 就这样。Right now, very classic problem example. I'm going to deliver that to you. Very classic. Okay. If I just give you that kind of problem, and I can test your understanding about chapter 4 and chapter 5 simultaneously. All right, so this problem is very important. All right, next page. The problem solving steps. The problem solving step is that Draw shear force and bending moment diagrams, chapter 4. And calculate the centroid because you need to determine neutral axis. And second one, you need to calculate the first and second moment of the section. Why? Because the first moment is for Q, the second moment is for I. Okay? And then calculate normal stress and shear stress. Yeah. So substitute that. Okay, so you can see many steps. Wow. Let's get it. Okay, so this is the problem, and sorry. Hey. Hey. Okay, so this is a distributed load Q equal to 28 Kn divided by N. Okay, again, this is, of course, this is side view, right? Okay, this is a side view. Z is toward you, so this is side view, of course. Okay, and it wants us to determine the point C here, sigma C and tau C and point C. And this C is 75 millimeter above to the bottom surface, not the Y, not the neutral axis. So this is from bottom. Okay. And the point distance to the B is 200 millimeter. All right. So basically, it is asking another time to determine my drawing score, drawing mark. Okay, C here, there's lines here, and it's really difficult to draw. Hey, hey, what's that? Hey, hey, sorry. Hey, hey, 啊，对不对不对，should be a middle. Hey, hey, you understand what I'm talking about? What I'm drawing? Good. Well, I'm sorry that maybe it should be symmetry. I'm sorry, it's really difficult. But maybe I'll draw that again. 有点那个，有点求好心切啊！哎呀。Anyway, so it looks actually symmetry, all right? Okay, and suppose. Okay, so we need to determine this sigma C, this value. Okay, this is sigma C normal, right? Normal. And of course, tau on that line. All right. Whew, very difficult. Okay, sorry, I should make it. So this is sigma C. sigma c. I will make it different that and this is tau c. All right. And I'm going to draw a really important lines. The yellow part is actually this. All right. Be careful. Be careful. This green, this yellow cross section, you cannot see in the problem, right? They only appear when I cut it, when I draw the three-dimensional view. All right. So this is the pink, yellow. All right. So now you need to draw the shear moment diagram. All right. So this is V and this is M. And it must have something we need to determine here. And it will be okay, looks like this. And this is VC. VC equal to 8.4 kn, not that minus sign. Be careful, be careful. This is minus sign. And I don't want to determine that yet. MC equal to 2.24 km dot n. All right. You need to draw it by yourself here. Right. So you have VC and MC for this cross section. Again, I need to put emphasize here is cross section view. Cross section view. Okay. You notice that I did a lot of effort, put a lot of effort on explain to you which is cross section, which is side view, because your senior made a lot of mistake because of this. All right, including me, including myself. Okay. And this figure, this problem is really easy, lucky, because this is a beautiful shape. You don't need to determine the centroid, neutral axis, because you already know that this should be in the middle, right? So all you need to do is just substitute all the value. I equal to BH3 divided by 12. 1 over 12, 25, 103. It's become 2.083 times 10 to 6 millimeter 4. So you got I, so you have 1. Sigma C equal to minus M Y divided by I equal to minus 2.24 times 10 to 6, 25, 2.08 times 10 to 6, minus 2, 6.9 M per. Okay, so sigma C is the compressive. So you can see that why I didn't say this is compressive. Okay, because I don't know it yet. The MC is positive or negative. Now we know this is positive, so it should be so it's tensile or compression. So you see, I didn't draw it at the first time because I'm not sure if this value is positive or negative. Okay, so this is minus. So it should be compressive now. Compressive. Okay. And I will continue this lecture to tomorrow, and I will show how to determine tau C and draw the sketch the stress element next page. All right. Thank you. If you have any questions, come here. All right.哦，那我等一下把那个录影关掉。摘要什么摘要？
那个要讲一篇叫论文摘，是第一页要出来。
我忘记我们在讲什么。
那个比赛。
什么比赛？哦。等下看一下他们有没有问题，听得懂吗？非常好。你以前是哪个学校的？
高中。
对啊，
高中历史。
的。